let's look now at how to add and subtract fractions. Okay, now if you've got the same denominator, like here, it's really easy, okay? So just think to yourself, what's 2 apples add 3 apples? It's 5 apples. What's 2 cars add 3 cars? It's 5 cars. What's 2 sevenths add 3 sevenths? It's 5 sevenths, okay? And you can see here that we're adding the numerators, and that denominator stays the same. Okay, I don't do 7 add 7, okay? 2 apples add 3 apples isn't 5 double apples, okay? 2 sevenths add 3 sevenths is 5 sevenths. I don't double the 7, okay? So that denominator stays the same, and we're going to see that happening throughout, okay? But the problem comes when the denominators are different, okay? So if I've got 1/2 add 1/3, let's draw it. You know, I always love to draw a picture, even though I'm very bad at drawing, okay? So here I've got 1/2, and here I've got 1/3, and I want to add these together. Now, it's not obvious what it's going to make just by looking at the picture. I need to kind of be a bit clever here. So what I'm going to do is I'm going to split, and we did this before when we were ordering fractions. I'm going to split, it's maybe a bit hard to see, but I'm going to split each half into 3. So instead of being 1/2, I've got 3 bits out of 6, okay? And I'm going to split each of these thirds into 2. So instead of being 1/3, now I've got 2 6. Oh, and now look, this is very easy to add together. 3 add 2 is 5 6. Denominator staying the same. Okay, how would I set that out in maths rather than pictures? Well, what I've done here in the picture was I took that 1 and I split it into 3. I made it like 3 bits. I multiplied that by 3. And instead of having 2 bits, I split each of those 2 bits into 3. So it's like I've multiplied that by 3. And over here, I took each of those 1 bits, like the 1 bit that's coloured in, and I split it into 2. I made it into 2 bits. And the 3 bits all together, they were also split into 2 each one, so I've got 3 times 2. And then that gives us 3 6 add 2 6 is 5 6. Okay, now you should notice here maybe I've done 2 times 3 and 3 times 2. Okay, so it's like I've multiplied by the number on the other side. So I've done the 2 times the 3, 3 times the 2. And let's see if this works out for our next one. So I'm going to do 4 times 5 and 5 times 4. So I've got the same thing on the denominator. Okay, now remember, for equivalent fractions, to keep this the same, to keep it equivalent, if I'm multiplying by 5 on the denominator, I better multiply by 5 on the numerator. Okay, if I'm multiplying by 4 in the denominator, I better multiply by 4 in the numerator. Okay, to keep everything the same. And now let's just do all our sums. I've got 3 times 5, that's 15 out of 20. And I'm taking away this time, always pay attention to what the symbol is. 2 times 4 is 8 out of 20. So I've got that same denominator. I need to have that same denominator. Okay, and now I've got 15 20ths, take away 8 20ths. That's 7 20ths. Okay, so all I'm doing there is subtracting the numerators. The denominator, once I've got those denominators the same, I keep them the same. Okay, and I can be a bit clever as well. Okay, so 7 times 14, that's quite tricky, and 14 times 7, that's quite tricky. Okay, why don't I just do 7 times 2 to give me 14? And then I'm going to have a common denominator. So see if you can. Try and be a little bit clever, okay? You're looking really for the lowest common multiple. If you've seen that before. So this, what you're looking for is the smallest number that's in both times tables, the smallest number that's in the 7 times table, and the 14 times table. And that's 14. 14 is in the 7 times table, and 14 is definitely in the 14 times table, okay? And that's fine to only change one of these. So if I'm multiplying that by 2 top and bottom, I'm getting 20 out of 14. Doesn't matter that that's top heavy at all. And I'm taking away 13 out of 14. Okay, so this one stays the same now. I've got my denominators the same. I'm good to go. Okay, 20 to take away 13 is 7 over 14. Now, this is a nice answer, I suppose, but it could be better because always check I can simplify this fraction, okay? 7 and 14 are in a times table together, as we know. They're both in the 7 times table. 7 divided by 7 is 1, 14 divided by 7 is 2. So this is just a half. Always simplify if you can, okay? If you're watching this in Scotland, you will drop marks in every assessment you do if you do not simplify. I don't know what the rules are in other countries, but I suspect they're the same. Okay. Let's have a look now if we had, so we had a top heavy fraction there, and that was very easy to deal with. It wasn't any different to dealing with a normal non-top heavy fraction. But when we've got mixed numbers, things are a bit different, okay? Now, I'm going to recommend you do it one way, and I'm going to show you another way to do it, okay? So I'm going to strongly recommend that you make both these numbers top heavy, okay? Why? When you are multiplying and dividing, which you will be soon enough, you will need to make these top heavy, okay? So it kind of makes sense if there's always one rule. Also, when you're subtracting, as we'll see, things can get a bit messy if you don't change it to a top heavy fraction first, okay? So I'm going to strongly recommend you use method 1, but I'm going to show you another method because a lot of kids like that other method, so that's fine, okay? So method 1, I'm going to make these both top heavy, okay? So if you can't remember how to do that, I would recommend you go and watch the video. So to make this top heavy, I'm doing 2 times 4, add on 1 out of 4, and I'm going to add on 5 times 3, add on 1 out of 3. So it's like I'm multiplying and then adding on the 1. 5 times 3, add on the 1. If you're wondering why you do that, go back and watch that video again, okay? So what's this going to be? 2 times 4 is 8, add on 1 is 9 out of 4. And 5 times 3, that's 15, add on 1 is 16 out of 3. And 4 and 3, so I'm going to times them by the opposite one. So I'm going to have 12, 4 times 3 and 3 times 4, they're both 12, is my common denominator. And if I'm multiplying by 3 on the bottom, definitely got to multiply by 3 on the top. If I multiply by 4 on the bottom, definitely need to multiply by 4 at the top. Okay, so 9 times 3, that's 27. 4 times 3 is 12. 16 times 4, oh, what on earth is that? Let's do a sum. 16 times 4. 6 times 4 is 24, 1 times 4 is 4, and 64. Easy peasy. 64 out of 12. Okay, now let's say you're in a test situation, you're likely to panic and get 27 plus 64 wrong if you do it in your head, trust me. So set out a sum and just stay calm, take a deep breath. 7 add 4 is 11, 2 add 6 is 8, add on 1, 91 out of 12. Okay, now see if the question's in mixed numbers. It's kind of polite to put your answer back in a mixed number. Okay, so do you remember how we do that? We divide. So you're thinking, how many 12s go into 91? Now, hopefully you know your 12 times table, and you're thinking, I'm not sure. Okay, so you could always have a good guess and check. Maybe you're thinking, maybe 8 12s. Maybe that goes in. 2 times 8, that's 16. 1 times 8 is 8. Add on 1, 96. Oh no, that's too much. Probably 7 12s. Let's see what that is. 12 times 7, 2 times 7, oh that's 14. 1 times 7, 7. Add on 1, 80. Oh, that works better. Okay, so there's 7 in there. 84 up to 91. How much am I adding on there? Well, it's going to be 7 out of 12. Okay, so my remainder is 7. Okay, so don't don't worry about doing a little guess and check, okay? If you're not sure, you can't remember your 12 times table, maybe you're in a test and you're panicking, just set out a bit of working. Maybe you could even put a cross through that one and a tick by that one, okay? Just to show that you know what you're doing, okay? Now let's make a bit more room here first. And let me show you the second method. Now I know this is a bit fiddly, okay? And maybe you will prefer the second method. So the second method is going to be a bit quicker than this. I'll tell you that now. But it's not a method that always works. So when I'm multiplying, when I'm dividing, and sometimes when I'm subtracting, things are trickier. Okay, so I'm going to show it to you, but use caution. Okay, so let me just write this out again because I've kind of scribbled it all over it. 2 1/4 add 5 1/3. Okay, I can just add the units first. So I've got 2 whole units, 5 whole units, that's 7 whole units. And then I'm going to add on my quarter, add 1/3, okay? Now, 7 I kind of don't need to deal with, okay? And if I'm doing a quarter at 1/3, okay, so I'm going to do 4 times 3 and 3 times 4. If I multiply by 3 on the bottom, I've got to multiply by 3 on the top. If I multiply by 4 on the bottom, I've got to multiply by 4 on the top, okay? So all together, in fact, let's do this underneath. I've got 7, and then that's 3 twelfths, that's 4 twelfths, okay, that's 7 and 7 twelfths, okay. Definitely easier mathematically, okay, so I'm not telling you not to do this, but just exercise caution. Let me show you what can happen sometimes with the subtracting. Let me show you how things can go wrong. Okay, so I'm going to do it again, method 1 and method 2, and you can decide for yourself which method you're going to use. So my preferred method, even though it's a bit trickier, and you know I love maths, I love doing all those little calculations, so maybe that's why I like this method better. Okay, so I've got 3 2/5 and 1 5/7. So I'm going to make it top heavy. So I'm going to do 3 times 5 add 2. Out of 5, that denominator stays the same, and I'm taking away 1 times 7, 7, add on 5, you could maybe even have done this in your head, this step at least, 3 times 5 is 15, add on 2, 17, out of 5, 1 times 7, 7, add on 5 is 12 sevenths, okay, and the numbers are a bit not very nice, but here we are. So I'm going to need to multiply that by 7 top and bottom, and that by 5 top and bottom. So I've got 5 times 7, 7 times 5, always multiplying top and bottom by the same thing, okay? And now I probably want to do some sums. So 17 times 7, 7 times 7 is 49, 1 times 7 is 7, add on 4, 119, okay? And 12 times 5, maybe you know, how could you do that in your head, I suppose? I suppose for multiplying by 5, I quite like to do multiply by 10 and then half it. So 120 and then half it, that would be 60. So all together, I'm going to have 119 out of 35. And I'm taking away 60 out of 35. Okay, 119 take away 60. Well, that 119 is very close to 120. 120 take away 60, that's me back to 60. But I'm 1 short, so I'm down at 59. Out of 35. And again, that's top heavy. Let's change it back to a mixed because the question was a mixed number. How many 35s go into 59? Well, only one. Okay, 2 35s would be 70. Okay, and what's left over? It's 24 out of 35. Now, are they in any times tables together? Well, one way you can think about it is by kind of splitting things up into primes. 35 is 5 times 7. Okay, and those are both primes. I can't split them up anymore, okay? Is 24 in the 5 times table? No, it's not. Is it in the 7 times table? No, it's not. So there's not going to be anything in common there, okay? So that's me done. 1 and 24 35ths, okay? Let's try doing it the other way, and we're going to kind of run into a bit of bother fairly quickly, okay? So I'm going to do 3 take away 1, it's 2, I'm doing my units, And then look, I've got 2/5 take away 5/7. Okay, so far so good, nothing wrong with this. Okay, so I'm going to do 5 times 7, 7 times 5. So I've got my common denominator. If I'm multiplying by 7 on the bottom, I need to multiply by 7 on the top. Multiplying by 5 on the bottom, I need to multiply by 5 on the top. So I've got, well, I'm adding that one. So I've got 2 as my whole number part, and then I've got 14 out of 35, and I'm taking away 25 out of 35. Okay, 14 take away 25. That is what, -9? Is that right? Yep, I'm going to draw my open number line. So I've got 14, and I want to take away 25. So I like to take away 14, get me to 0. How many more? Oh, look, and there I've got it wrong. So I take away 11 to get me up to taking away 25 overall. See, shows you anyone can get these things wrong. So I'm taking away 11/35. Now that is not a good answer. Okay, so what I need to do here is convert one of these units into 35/35, and that's fair enough. Do you know, one whole unit, I'm not even going to draw this accurately, but if I split that into 35 equal bits, okay, it's 35 out of 35, okay, it's 1 unit. So instead of, I'm going to write this as 1 whole unit, and then the other one is 35 bits out of 35. And now I can take away my 11/35, no bother, okay? So I've got 1 and 24/35. Same as before. Now, between method 1 and method 2, there's maybe not a huge amount of difference in terms of working. I think method 1 is easier, okay? See if you know your tables. The trickiest thing we did there was 17 times 7, okay, which is not that bad. You know, you can set out a sum for that, okay? But here there was a bit of a conceptual difficulty here. That negative number is 1. I had to draw a number line. I got it wrong in my head, okay? So just be a bit careful, and you'll see for yourself when we're multiplying and dividing, we'll need to make everything top heavy. So sometimes it helps to have the one method for everything. Anyway, that is how to add and subtract fractions with a dangerous choice that you can make in there.